When you consider RCS services, pretty much everything centers around messaging. So even though we have service features like geolocation and audio transfer, file transfer, presence information or social presence information, these often still relate to the overall theme of messaging, and we'll pick that theme up momentarily. So this section is really talking about the different features associated with messaging. We'll take the general messaging service to begin with. We'll then consider the use of chatbots in RCS business messaging. And then finally, we'll talk about enriched calling. So up on screen, we've got the kind of full set of features related to the RCS messaging service. So what exactly are we trying to standardize, and what do we expect from the messaging service when it gets deployed by an operator? First point to note is that you might not see everything, because it still can be up to the operator, particularly if they are controlling the RCS services, as to whether or not certain features may or may not be deployed. It's also worth remembering that we are largely comparing this to SMS and MMS, because RCS messaging is what is designed to replace those legacy systems. We know that SMS and MMS are inherently limited, but we know that they are still widely available. The idea is RCS messaging will eventually replace them. We're not going to hang on to 2G and 3G forever, and we do need a replacement that is better than naturally what we have already. So what is the RCS messaging service actually offering? Well, I guess the fundamental capability is standalone messaging. This is just the direct replication of sending an SMS text or sending an MMS. So just the ability to send a message to another party. But we can kind of have nuances within this overall umbrella of standalone messaging. So for example, we've got the notion of one-to-one chat. So this is a kind of interactive, almost real-time messaging session where you're actively communicating with somebody in a kind of instant messaging format. We've got group chat as well. So several people can join together in a group and communicate that way. Now, if you use Microsoft Teams, for example, then one-to-one chat and group chat are very routine features. But we've got lots of messaging platforms like Slack as well, for instance, and various others, WhatsApp included in that provide those kind of one-to-one and group chat facilities. Remember, the point to RCS doing this is it's just available on whatever handset, whatever operator network you happen to be using. You don't need to pay Microsoft. You don't need to download a specific app, etc. Now, within our messaging service today, we do expect generally that file transfer as a capability is available, and that file could be many and varied. So there could be all manner of different file formats that we would want to exchange during a messaging session. So file transfer is a key feature, as is geolocation services. Now, this is one example of a geolocation service whereby a particular user says to a different user, I'm going to be in this location, and it might be at a specific time. So you push that geolocation service, or you push that location to the end recipient as part of the messaging platform itself. Note though that there are other geolocation capabilities available in RCS overall. We've also got audio messaging. Now essentially this is almost like file transfer, because the audio file, whether it's an MP3, MP4 video message even, okay, those are capabilities that we can support during our messaging service. So we can transfer audio, we can also transfer video clips as well. We've also got the notion of extended messaging. Now this helps to monetize the messaging service. The idea behind extended messaging is to support things like B2B communication or B2C communication. So it opens up the messaging platform to maybe a corporate entity, some kind of organization or business, and they can use this as a medium to communicate with their customer base. So chatbots are one aspect of kind of RCS business messaging, but extended messaging, being able to communicate with a particular customer base, is also a critical feature. And then finally, inappropriate user behavior handling. So if there is a user who is misusing or abusing the messaging service, we need mechanisms by which we can deal with those individuals and basically stop them from causing problems with the service. So that's the overall messaging service. Remember at the start of this discussion, I said that we need to compare this with kind of what we've had for some time, which is SMS and MMS. And a useful way to do that is through this kind of comparison table, which just shows you really the benefits of RCS messaging. So if, for example, we look at the content type related to the three different mediums, we know that SMS is kind of plain text only, no real media transfer. It was only when MMS was introduced that we were able to send beyond just text, things like images, audio and video. Well, with RCS messaging, we've got both SMS and MMS capabilities, but more besides that. So we've got the ability to send rich cards. So these are effectively graphics that you might be able to interact with in a messaging session. We'll see some examples of a rich card coming up. And then you can see carousels of rich cards, which again, we'll see momentarily. Different buttons, they're called chips. And we've also got really rich media. So a much better platform for sending specific content. In terms of character limits, we were plagued with, well, depending on your age, we were plagued with the kind of character limit of 160 characters per message on SMS. Obviously, that improved with MMS. And then with RCS, it doesn't really have an impact. There's no really strict limit. Different media, well, we know SMS was text only. MMS was designed to be multimedia. And then RCS just extends it even further. Really high quality multimedia, augmented with things like locations, file transfers and such like. How do we deliver it? Largely cellular for SMS. To begin with, it was using circuit switching. To a degree, you can use packet switching with SMS as well. You can also use IMS. And in fact, the reason I mention packet switching is if you use IMS, you could potentially deliver a text message using your packet switch network. It doesn't really happen very often. So we've only really focused on circuit switch network and IMS. We know that the circuit switch network is gradually disappearing. For MMS, we really do need a packet switch network. It's usually associated with delivery over at least 3G, but again, we're losing 3G. IMS delivery would rely on packet switching there. For RCS messaging, it's really all about packet switching and IMS together, really. So really, we're talking about a 4G or a 5G delivery mechanism. We can also use Wi-Fi as well. And I guess you could use Wi-Fi for MMS delivery as well, particularly if it's IMS based. All right, remember IMS is access network agnostic. So as long as that access network can provide an IP transfer mechanism, then we're able to send SMS, MMS, or RCS. In terms of the UX, well, SMS is really limited, basic text. It does improve with MMS, but RCS is designed to provide an app-like experience, a really rich experience for the user, and really similar to what we're so used to with our kind of over-the-top messaging platforms today. What happens if SMS isn't available? Well, not a lot is the answer. We don't really have any fallback mechanisms for SMS. For MMS, well, if you don't have MMS available, you may be able to send SMS. And for RCS, again, if RCS services aren't available, well, we can fall back to SMS or MMS. But really, in today's network, you'd like to think that we do have pretty ubiquitous 4G coverage, and 5G coverage is improving all the time. In terms of the cost, well, the cost of an SMS used to be absolutely extortionate when it was first introduced, but we know now that most of the time it's free, it's bundled into an existing package, and that's the way it's actually delivered today. If you send an MMS though, you can still be charged quite significant rates for MMS. And I guess for both SMS and MMS, if you are roaming, then charges can be quite significant for roaming, and it's where operators can continue to actually make money from SMS and MMS. For RCS messaging, because it's so heavily data-based, you need a 4G or 5G connection or Wi-Fi. It's usually related to your your data allowance, and in some cases, it may be bundled as messaging. So there's just a bit of a comparison there, just so you've got an appreciation of kind of where we've been and where we are today. A key aspect of RCS business messaging is the use of chatbots. Now, love them or hate them, chatbots are an important tool for organizations because they basically give an opportunity to filter out the more basic customer engagements that a human dialogue isn't really required for. So with a chatbot then, there's several key features that we need to consider, and the first one is chatbot discovery and management. So if you're on a particular operator network, you need to be able to access information about the chatbots that are available in your particular RCS network. So there's a whole discovery and management mechanism. First, you need to be able to discover a list of chatbots, and then that list needs to be managed. And then once you know which chatbots are out there and available, if you need to use a chatbot, whether it's AI or human driven, then you need to grab chatbot information. You need to understand the contact address of the chatbot. You need to understand the features that the chatbot supports and also the name of the chatbot. Now, I say you, but this is information that is being sent to the device to be presented to the user as necessary. We've got to consider privacy, so there needs to be a level of protection of any traffic that gets exchanged between the user device or the client device and the chatbot itself. And we also need to make sure that we can react if a particular chatbot service is being misused or abused. Traffic identification is quite an interesting one. So traffic related to chatbots will be between a certain pair of IP addresses, source and destination. It will have a certain traffic profile. And it might be that we might want to treat that particular chatbot traffic stream with a preferred level of quality of service. It's really up to the operator how they want to manage this service, but crucially sell it to the chatbot owner. So if the chatbot owner has the proposition of, hey, with our chatbot, we will give your chatbot traffic a certain level of quality of service over and above just regular internet traffic, then that's quite interesting for the owner of the chatbot. So we need a means by which we can identify chatbot traffic and give it preferential treatment as necessary. And that will always mean that the access network, whether it's 4G, 5G, etc., will need to be aware of that traffic profile. So there would need to be some kind of interaction between the chatbot services hosted at the IMS and the transport or the access network itself. And that's usually done through policy control. We've got deferred messaging. So there will be times when the chatbot may need to communicate with the customer or the end recipient, and the end recipient's actually not there or just away temporarily. So the end recipient might, for example, set windows of time in which the chatbot is allowed to engage with them. There might be a failed delivery, so we might want to defer that messaging and try again at a later stage. And that's just all there to enhance the user experience, to make sure they get the messages they need. Now, what's quite critical for chatbots is the use of rich cards and chip lists. Now, the easiest way to imagine what this is to see an example of it. So that would be an example of a messaging service, potentially with a chatbot, where you're presented with, actually it's a carousel of rich cards. So you can see that this is a holiday chatbot, and we've been offered a series of different holiday destinations. So we've got the Maldives, Santorini, Bali, etc. So they're on a carousel, and you might see up to 10 of these rich cards on the carousel. And notice that for each rich card, there are chips. So these chips are effectively buttons that you can click on. So they're call to actions for the user of this service. But this is a really, really important way to communicate a product to a customer. And it doesn't just apply to holidays. It might be that you're trying to buy a particular training course, for example. So there might be an RCS messaging service, even a chatbot service for Mpirical training. And then finally, we've got the use of critical chatbots. So in some cases, for critical situations or critical communication, chatbots could still potentially be used, particularly when there's been a wide-scale incident and we need to communicate information to lots and lots of different users who may have questions. Now, this might be the general public, but it could be in reaction to a particular event, a particular crisis. There could be, for example, a kidnapping, and a chatbot might be introduced to allow, it could be thousands of members of the public to actually interact and provide information as appropriate. So we've got lots of different features associated with chatbots there, and it's a key enabler for RCS business messaging, which in turn is a real opportunity for operators to monetize access to their RCS services. The last area we're going to consider is enriched calling. And a key point to note here is that we're not talking about the actual call itself. I've already said that these days RCS isn't really focused on voice. Operators have gone down the VoLTE or the voice over new radio route. Now, VoLTE and voice over new radio, as an aside, are GSMA specifications anyway. So we've got the likes of IR92 for VoLTE and NG114 for voice over new radio. So they are already in the GSMA camp, but we're keeping it in with messaging with respect to RCS. So when we talk about enriched calling, we are talking about a call, but we're talking about the way in which RCS messaging can actually be used to enrich that call. And you can see there's several different phases of the call that we can encounter that can be improved through enriched calling. So for a start off, we've got the notion of the pre-call experience. So before we actually conduct the phone call, one of the end users is able to compose information prior to that call taking place, and it's sent potentially before or even during the call establishment. So the calling party number is fairly basic anyway, but maybe the subject of the call, which is something we don't really see in a lot of networks, but could potentially be really useful. The location of the calling party, a picture of the calling party. So if this information is sent during the call establishment, it's a really powerful way to actually enrich a call. What about during the call? Well, this has been talked about for a long time. We're in a call, it's a key feature of SIP really, but we're in a call, and during the call, we actually send other forms of media. So you can see we're sharing content such as chat, files, presentations, location, background audio and video. And this happens already today. You could be in, for example, a Microsoft Teams call, a group call, and in the background you're also exchanging files, etc. during the call. It's a prime example that we see already today, but a very powerful use case and a really useful tool. But what about after the call? Well, in particular, we're talking with respect to the post-call experience. When a call goes unanswered or is maybe rejected, we can compose again information related to the call, which we can send to that call party. In essence, it's potentially almost like a voicemail, but there's other media that we can send other than audio to assist with the kind of close down or the rejection of that call. And then finally at the end there, we've also got the enrichment of call logs. So when we do use enriched calling, these call logs can identify exactly what was shared during the pre-call or during the call. So it's almost like a summary of the call all in one kind of document or one kind of medium to allow the recipients, either end, to just evaluate what was actually exchanged. So lots of different techniques are available in Enriched Calling. Support for it varies from one operator to another. So for example, in the UK, you don't routinely see it used very often unless you're specifically using a business service that's offered by a particular operator. It's not routinely found in the consumer market. In other operator networks around the world, it is gradually being deployed.